Use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the given curves about the x-axis. So for this question, we have the function x is equal to the square root of y, and we can see there's the function x equals the square root of y, x equals 0, there's the vertical line, and then y equals 1, which is the horizontal line. So because we're going to then rotate the region about the x-axis, that means that we are going to revolve it around the x-axis in that way. So we're going to create our cylindrical shell that way. So what we're going to do is we're just going to go ahead and then take a piece from this region and then create our cylindrical shell. So that means that we're going to have this cylindrical shell. It's going to look like the following. So you can see that we're going to continue to draw the rest of the cylindrical shell. Okay, so here you can see what the cylindrical shell looks like. Okay, so what we can also notice is, okay, now what is the radius of this function? Well, the radius of this function is in terms of y. So therefore, you can see that the radius function is going to be y. Okay, and so we know that the radius of the function is y. And now, what is the height of the function? So the height of the function is the actual function itself, and that height represents the square root of y. So therefore there is the height. So that's the height, and this is the radius, and we know what the thickness is. So first thing we're going to do is write out that the radius is y, and the circumference of that cylindrical shell would be the distance around that, and that's going to be 2 pi r, but our radius is y, so therefore it's 2 pi y. And then the height represents the function, which is the square root of y. Okay, so then we need to know what represents A and then what represents B. Well, since we're dealing with in terms of y, we're going to look at the y values as our endpoints. So we know that the lower bound is 0 and then the upper bound is going to be 1. And so now we can go ahead and then apply the integral. So we have the volume, which is going to equal the integral going from 0 to 1. And so we're going to take the circumference, which is 2 pi y, and we multiply by its height, which is the function the square root of y, times the thickness, which is dx. So now we can factor out the constant, which is 2 pi. And so what we have left is y times the square root of y dx. Now keep in mind that when you multiply with the same base, the square root of y is 1 to the 1/2, and that is 2 over 2. So when we multiply with the same base, we add those exponents, so we get y to the 3/2. So we get 2 pi going from 0 to 1 of y to the 3/2 dx. Okay, and so now what we need to do is now find the antiderivative. So we have 2 pi So that means to find the antiderivative, it's 3 over 2 plus 1, which is 2 over 2, over 3 over 2 plus 2 over 2. So then that becomes the reciprocal of 5/2 is going to be 2/5 y to the 5/2. So we have 2/5 y to the 5/2 going from 0 to 1. Okay, so let's go ahead and then evaluate at 0 to 1. So we have 2/5 times 1 to the 5/2 minus 2/5 times 0 to the 5/2. Well, we know that gives you 0. And so 1 to anything is going to give you 1. So 2 pi times 2/5 is going to give us 4 pi over 5. And so therefore, the volume is 4/5 pi, or 4 pi over 5.